Okay, we've got another integration by parts example here. It's the integral of the quantity x squared plus x plus 1, that's times e to the x dx. So identify some parts here. These two things are pretty much unrelated, so you could let x squared plus x plus 1 be your u, then your e to the x dx be dv. The nice thing about the dv here is that when you integrate e to the x, you keep getting e to the x, so you shouldn't be too scared of that. Let's write it out. U is x squared plus x plus 1. That means the du is 2x plus 1. The dv is e to the x, so when we integrate that, we get v being e to the x. Okay, so remember that to get from u to du, we took the derivative. And to get from dv to v, we integrate. Okay, so let's kind of write this out. So what do we have? We have that our integration will equal uv. Well, u is x squared plus x plus 1, and that'll be times v, which is e to the x, minus the integral of v, which is e to the x, times du, which is 2x plus 1, and there should be a dx there with it. Sorry. Alright, so labeling everything just so you can see where it came from. Here's u, here's v, v, du. So the unfortunate thing here is that we did get part of it that we get to keep, so we're just going to keep pulling down this first part, the u times the v. It'll come all the way down to our last answer, whatever that might be. But the second part, the minus integral of e to the x, 2x plus 1 dx, we're going to have to rework that. So let's just write it down a little bit better. So it'll be the integral of 2x plus 1 times e to the x. I'm rearranging it so I can see it again as a new u dv. So this is a new integration by parts here. So in that case, the u is 2x plus 1. That makes the du 2 dx. dv is e to the x dx. So the v will be e to the x. And again, there's the derivative. And on the other side, we integrate. So let's see. Still pulling everything down. What do we have now? We put it back together. We got this minus way out front. And then we'll have a uv. So that'll be 2x plus 1 e to the x minus the integral of v, that's e to the x, times 2 dx. Okay. So take a look at that. So there's a minus that was in front of the integration, still bringing everything down. So now we got another piece that's already handled. Okay, but let me mark these again. So here's a u, v, v, du. So if we pull everything down, and we may have to slide down a little bit here, but we've got what we've already had. We've got x squared plus x plus 1 times e to the x, and then we'll have minus 2x plus 1 e to the x. And this minus is going to go through the parentheses here, so we'll have plus the integral of 2 e to the x dx. Now the nice thing about this is we finally gotten to a place where we don't need an integration by parts again. Okay, we can go ahead and say the integral of 2 e to the x is itself 2 e to the x. The 2 carries as a coefficient, and the e to the x derivative, integration is itself. So in the long scope of things, the original problem, which was x squared plus x plus 1 times e to the x dx, is, the integral of this thing is everything that we've already found, all the parts that were there. X squared plus x plus 1 times e to the x minus 2x plus 1 e to the x. And then we said the last integral here will be itself, 2 e to the x, and that'll be plus c. So we have the original problem and everything put together, gives us a complete integral. So we had to use integration by parts twice there. We developed something we could continue working with, but you do have to realize that you might have to switch your u and your v somewhere in the middle of the integration by parts. Thank you.